Okay, then I shall start. Maybe I start recording for Han since she won't be able to make it here. Oh, okay, cool. Let's get started for this week. And once again, I'll see you guys on the website. You guys remember paperland.sg. Amy and I guess I'll constantly share my screen to make it easier. Amy is in, I see. Becky?
I can see the person named Bala here.
Yeah. Yeah, I was showing a friend what we were gonna be doing today. Becky, are you able to join us? Alright, I see
Yeah.
she's in as well. Okay, oh yes, that's what you guys were working on last week. Okay, so come and take a look at my screen recording first. I'm going to tell you guys what we'll be doing today. So, can you guys see my screen?
Yeah.
Alright, so today we're going to be looking at how to draw this. What is this?
I guess snowflake.
Yes, a snowflake. Right, it is a snowflake. Let's see what snowflake looks like in real life. So what makes snowflake special? You guys know?
The shape.
Yes, the shape. It is really interesting. What about the shape? Do you find interesting about snowflakes? Have you guys seen snow before?
Yes.
Right.
Yeah.
I was just wondering. So, well, snowflakes, if you look at this, every snowflake is unique. It has this unique pattern. But one interesting thing about snowflakes is that it has this repeating pattern that makes it very mesmerizing, at least to me, right? So today we're gonna be learning how to make a snowflake like this one. So this specific snowflake is interesting because for at any scale, right, the snowflake will look the same. So for example, right now it looks like this. At a different scale, it looks like this, which is similar. If I zoom in, it looks like this as well. Can you spot and see what the base shape of this snowflake is? Can you see what is the repeating shape that it is making? Okay, so you guys don't know, but it's okay. Today, that's what we'll be exploring today. So we're gonna start off by making a new shape like this. Let's make a triangle for now. How do you make a triangle? Try to follow along for this. Oh, we don't have to make a triangle. I want you guys to make this particular shape here. Yes, can you guys try to follow along and make this shape?
Okay.
Nice one, Amy.
Thank you.
Interesting. Okay, Becky's there too. Fantastic. So what we're gonna do is we're gonna make this shape a custom command. I'll name mine, you can name yours anything, but I'm gonna name mine Kosh after the guy who invented this shape. So I'm just gonna name mine Kosh, name yours whatever you want to name yours, make it into a custom function. You guys got your custom function? Yep, remember to call the function. Nice. Okay, I see Becky's there. Amy. Triangle. Okay, cool. So at this point, if you guys look at my screen, do you all remember what we did in the previous lesson? Amy, Becky, do you guys remember?
Recursive?
Recursive. Yes, recursive. What does that mean to you?
Calling the function in itself?
Yes, it's the function calling itself. Basically, the function is kind of duplicating itself. You're absolutely right. So right now, if I add a Kosh function at this line, as you can see, I've commented it out right now. So before I do anything, if I were to write this command here, what do you think would happen? What do you think you'll see? Any guesses?
Will continue draw this shape.
Right. It will continue to draw the shape. You're absolutely right. So you'll continue drawing the shape all the way to the right. So if I do it this way, ta-da! There you go. And we add a wait function here. You can see it animating all the way to the right. So far, okay? So we also figure out a way to draw a specific length of this. So we don't want this to go on to infinity to the right, correct? So we also did this thing where we added a condition. So, oh yeah, we don't have the condition yet. Okay, cool. Another thing that we could do is we could add a variable to determine how large this is, right? So I'm gonna add a variable here, length, and I'm gonna replace it for all the forward commands like this, and I'm gonna put Kosh 100 here like this. Oh, I forgot the length here. So this is what will happen. Okay, all's good so far. Are you guys able to follow along? What do you think would happen if I make this length half each time?
Half each time?
Yes, I'm gonna half it each time. So I'm gonna divide by 2 here.
the triangle will be closer to each other.
Closer to each other? You are right. What else will happen? Do you give up? Okay, I'm going to divide it by 2 now. Do you guys guess correctly?
Oh. Okay.
Okay. Do you understand why this is the case, Amy?
The length gets smaller and smaller each time.
Yes.
So the shape became quarter size each time. Oh, that's cool. Yeah. At some time, each coach is closer to next coach compared to the previous one. No, yes.
Yes, so it's calling itself cosh every time. So it's doing the same code, but each time. So if you want, you can ignore what this is. Ignore this part first. Just look at what's happening here. So it's moving forward 100. It's turning left 60. Sorry, it's turning left. Then it goes forward. Then it turns right. Then it goes forward. Turns left. Then it goes forward. So this is what's happening here, right? Forward, left, forward, right, forward, left, forward. That basically draws this shape. And here at line 13, because each of the function calls itself, it will continue drawing the function again and again and again. But because each time it calls itself, it does half of its length. So what's this distance here? Amy, do you know what the length of this is at this point? Oh. I'm gonna add a label here. So
Oh, okay.
maybe 25, 50. So this will tell us the length of each line. The length of each line. Can you see that the length of each line is dividing by half each time? Right, so we started off with 100. So 100, 100, 100, 100. Then divide by 2 is 50, 50, 50, 50. Then it's 25, 25, 25, 25. Yes. I just want to make sure you guys are clear about why this shape happens. Do you understand, Becky?
Yeah.
Alright, Amy, how about you?
Yeah.
Okay, cool. So this is what happens when you recursively call something, which is nothing special. What I want to do is I want to create this other thing. Where is it? There you go. Here. So I want to create such a thing where this is the basic shape. I want the basic shape to be replicated each time, but instead of replicating on the right, like this, just now this shape continues on the right side all the way. What I want to do is before that, what I need to do is I want to make sure I can stop this at any point that I want. So for example, if I want to stop it at this point, what do I need to do? Do you guys know?
Set the rules while the length is less, then maybe 4 or something bigger than 10.
Yep. You're absolutely right. So when length is above a certain size, then I'll do what's inside. See? So you see it stopped at this point instead of going down to infinity. Okay, you're absolutely right. So if it's greater than 20, 25. It stops at here. It's 20 and here. Cool. So try to follow along up to this point first, and I'll show you what the next thing we're going to be doing with this. Yeah, so try to code along at this point. Don't look at how I did it, just from memory, try to recreate this. Just 3 picks, 1, 2, 3. Nice, Becky. Now just how do you make it such that there's only 2 peaks?
I think I typed exactly the same code, but I don't know why it didn't show anything on my screen at this moment.
Is there an error code on the bottom left hand corner of your screen?
Oh, yes. Okay. I'll try to.
Yeah, if you want to, you can share your
Yeah.
screen and I can help you and work through it together.
I think somehow the function is not defined. Let me see how can I fix it.
If you're stuck, you can share your screen. Okay, Becky, are you able to make it such that there's only 2 peaks? So 2 triangles?
still trying. Why it's not working?
Okay, excellent.
I try to share my screen now.
Okay. Yeah, because on the platform I could only see your code if it's correct. I should. Let me think about it. Maybe I'll redesign the interface such that when you guys have errors, I could see it too, so that it's easier. Just
Can you
thinking out
see
loud.
my-
Yeah, I can. Yes, I can see it. Let's take a look. Function triangle not defined. I see. Okay, let's see. Function Oh, you spelled triangle wrongly. Line 4.
Where?
Line 4.
Here. Triangle.
And
It's my
line
big
20.
Mhm.
Line 20.
20. Oh my god.
Okay, so if you see the error code, yeah, that's what it said just now. It said that the function was not defined. So very likely you spelled it wrongly. That's why we try to keep the function names short.
Okay.
Okay, right. Fantastic. You're on the right track. Beautiful. Okay, if you can't find where your code is, what you could do is... Oh. 停止值什么 Yes, you can stop the recording if you wish. If nothing is showing up, it could be that you're too far away. What you do is at the top right hand corner there are 3 buttons. Click the one on the left.
Yeah.
And it will help you recenter your screen. Awesome.
I still see nothing here.
You see nothing? Well, you can refresh your screen. If you refresh it, it should reappear. Because I think you drag it too far. Meanwhile, Becky, I see you're still stuck. Maybe I can help you along if you share your screen. Oh, are you done? Oh, yes, correct. That should be right. Yeah, so if I only want to see 2 peaks or 3 peaks, then how do you make it so? Amy, you can scream for help if you need help.
Okay, I'll share my screen again.
Nice. Okay, Becky has 3 peaks now. Fantastic, she's got it. Let's see. Maybe you can help Amy with hers as well. Why is nothing showing up on your screen? That's interesting. Oh, why do you define cosh twice? Why do you define it at level at line 1 and
Oh.
3?
So.
Interesting. Let me screenshot the error.
Oh yeah, it's coming out.
Yeah, okay, interesting. If you define quash within itself, it doesn't show any error. Oh, that's weird. Oh, Amy, you're done. That's fast. Nice. So how do you just have 3 peaks?
Or how many pigs are we going to make now?
If you just make 2 peaks, I just want to make sure that you are able to make 2 peaks. Yep, Maggie has 2 peaks. Nice. You're just playing around with numbers. Fantastic. Okay, everyone has 2 peaks. Excellent. So what is next? What is next is that we are going to, instead of doing this, which is rather straightforward, because this function just recursively calls itself again and again and again to the right. But we're going to do something a bit more complex. What we're going to do is I want this shape to repeat itself, but except this time the condition is that every line, you see this? So this line, this one line here, if you see my screen, this line here, I want this line to turn into another cosh triangle instead. So I want this to be another cosh triangle. So what I mean is, I mean this. So you guys started off with drawing this. I want it such that each line becomes itself, but smaller, but half its size. So take a look at this. Do you see the larger shape? 1, 2, 3, 4. This is the basic shape, right? Except this line is split into 3 components. You're drawing the shape itself again here, like this, like this, and like this. Yeah, so I'll leave it as an activity for you guys to try first, to do it. Do you understand? So the instruction is a bit convoluted. It's a bit messy. So just checking, do you guys understand what do I mean? So objective is to draw this. It's quite a bit of a challenge.
Using recursion?
Yes,
Or
using
just draw it?
using recursion. So think about the code that you have, which is a cosh triangle, right? So this cosh triangle needs to appear here. 1, 2, 3, 4. So here's a little bit of a clue for you already, which is that in the middle of the line, you should have a draw cosh function that draws this thing here. In the middle of this line, you should draw a cosh. In the middle of this line, you should draw a cosh function. Yeah. Oh, what? Oh no, you just did it. Amy just did it the brute force method, which is good, but that's not what we're going after. We want the function to recursively call itself. It's quite challenging. I don't know whether you guys will be able to do it, so I'm doing an experiment to see whether it's possible. Yes, Amy, that shape that you've made is what we want it to eventually end up being. Yeah.
I'm trying to think how to use the code itself. Code.
Yes, that's the big brain way of doing things. Because for your method, let's say I want to do again. I want every line to become cosh, to draw another cosh triangle, but at half the length as before. Then your code is suddenly gonna multiply and get really really long. Then I say I want to do it again, and I want to do it again, and I want to do it again. Then your code is just gonna be it's gonna get extremely long, even though the logic behind it is the same, which is that every line that I have now will turn into the cosh triangle but at half the length. So the logic is simple. So the code should be done in a way that is simple as well. Simple to read at least, not simple to do. Yes. Don't worry if you can't get it at the end of the day. I'm doing this as an experiment to see whether I can guide you guys through it. Here's the clue. You have to draw a quash shape at half the length in the middle of any forward line. That's the clue. If you guys give up, just let me know. Or if you're thinking through something, maybe you can think out loud and I can help you as well. Yeah, good. Good to add some comments to help you clarify your thinking. Nice one, Amy. So I see you wrote draw a course in the middle of the length. Okay, that's fantastic. So if you look at your course function, which lines have a length in it? Well, it's basically all the forward commands, right? So you're supposed to add a course function in the middle of the forward line. So then the question is, how do you do it? Becky, what's your approach? How are you attempting this?
I'm thinking about replacing forward command with cosh, but I know how to let it stop.
Forward command with course. Interesting. Okay, I'm gonna try it too. So all the forward commands are replaced with course?
But I couldn't let it work. It says it couldn't stop.
Okay.
You know how to let it stop to see if I'm on the right track.
Sure, come, share your screen. Let me take a look at it.
Maybe.
Ooh.
But I delete all of the code because it wasn't working.
You can. This is where you're at right now. Okay, so what were you trying?
Yeah. I was trying that cosh at first, and it said maximum command limit up. 8,800.
Yeah.
88.
Command limit reached because. Okay, what do you see on your screen? So you can close Amy's code for now.
Oh yeah, it's Amy's code.
Yep. So what do you see? If you
Oh.
Now if you close Amy's code and you just look at your own code. Yeah, oh, I see. You're trying to see what happened, right? What's the difference?
Yeah.
As in, her method is not exactly correct, but at least she's not hitting the command limit. You're hitting the command limit, right? So the question is why?
I'm trying to figure it out.
So if you close Amy's code for now, I want you to close it first, then you zoom out. So just scroll down on your cursor on the screen. Yeah. Are you able to zoom out? Do you know how to zoom out?
I know.
Yep, there you go. That's how you zoom out. Do it again.
Okay.
There you go. Yeah, then pull it. You see? So it's just basically
Yeah.
going forever to the right. Correct? And why do you think that your line 2 is not working?
It start drawing.
It only draws
It
when.
start calling itself.
What does line 2 do?
Line 2. Oh, let it stop. But still.
Yeah, do it at line 10 as well.
Oh.
There you go.
Oh.
Yeah, because it's going in forever because the length is not changing. Yeah, so if the length changes, then the length gets smaller each time. You see? Then the condition of when length is greater than 26 will kick in. Yeah. Okay, fantastic.
What's this not funny? like
Whoa! Amy, you should take a look at Becky's shape.
I don't know why it's like this.
Yes, okay, this shape is actually really good. I'm gonna get you guys to make your own shapes later. But I think it might be worth. Okay, I'll give it another minute, then I'll tell you guys the answer. Yeah, so for Becky, you gotta have some forward commands somewhere. And you also got a cosh in the middle as well. So that's the clue. Let me go and take a look at what Amy is up to. Amy, how you doing?
I'm checking some screenshot from last Sunday, and to see how can I combine.
Ah, I
How
see.
can I combine it together? Yeah.
Yes, you can
I'm
share
so,
your.
so far, yeah.
So far, yeah. So far.
I'm still at the same pace, and
No worries. Becky is here too. All's good. Do you mind sharing your screen? I can take a look at what's happening.
okay. I think nothing really changed. So, I try to put the divide the forward length like only for not here, like here, but it's not what we want. And yeah,
Draw a quash in the middle of length.
yeah.
Okay. Okay. A good attempt. It's a good attempt. I think it's time I show you guys how it's done, so that we can get on to the more fun part. Okay. I think guys, come let's take a look at my screen. I think you guys did a good effort to make it work. Okay, so let's recap. This is what we started out with. Tang 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 tang. This is a cross triangle, and what we want to do is we want to make this shape. This is the second shape, and what we're gonna do is for every line that goes forward, we want it to become a cross instead. So how many lines are there here? Can you see that there are 4 straight lines?
Forward.
Yep, you're right, Amy. There's 4. So what this tells you is that in here, the function, so there needs to be 4. There needs to be 4 cosh length divided by 2 in here somewhere. So there needs to be 4. Okay? That's how we know it's correct. Right now it is drawing. Okay, let me simplify the code so that's easier for everyone to see. Okay, so this is where we're at. We've drawn 1. Okay, so the trick is that every line in the middle of this forward line, I draw a cosh. So I'm gonna do exactly that. Just in the middle of a forward line, draw a cosh. This is exactly what I'm gonna do. So step 1 is I'm gonna cut the line in half for now. So instead of writing forward length, I'm gonna write forward length divided by 2. You see? So it's exactly the same thing. I'm gonna replace this one with for length divided by 2. You see, there's nothing, right? It's the same. Just that I've broken it into two parts so that there's a middle that I could add something in here. I'm gonna do the same here. And I'm gonna do the same here. Okay, so far nothing has changed, and that's good. Now in the middle of each for command, I'm gonna add a cosh length divided by 2, like this. You see? At this point, I'm gonna add another one, I'm gonna add another one, I'm gonna add another one. So what it takes is that there's a line here, so this line used to be this line, and I cut it in the middle, and I draw a cosh here. And if I've done it right, this is what we'll get. See? In the middle of this, there is another cosh that is half the length. Ta-da! So we got this. Follow along so far? So now, if I make oh, it shouldn't be length divided by 2, I think it's 4. Maybe 4? Oh, I guess it's not. It's just 2. Interesting. So anyways, you draw a cosh in the middle of this. Now the question is, what happens if we want to do this, continue doing this? So for every line, I want to do the same thing. I want to draw another cosh. I want to draw another cosh. What I need to do is, I will just change the final ending condition from 25 to 10. Can you see? It's the same
Yeah.
triangle pattern, repeated each time, but it gets smaller and smaller. But it does the exact same thing. If you look at this, can you see this pattern was the second iteration from before? Just that it has occurred again. So instead of doing 10 times, let's say I stop only at 1. Oh, where is it? There you go. Ta-da!
Oh wow.
Maybe length. I'm not too sure as well. I'm actually playing around. Yeah, see? So, oh, it's gonna go even more. Let's make this faster. Yes, so what we've created here is a ever repeating pattern that is just constantly repeating itself at various scale. Can you see? Then it creates this self-repeating pattern. So there's a term for this. These things are called fractals. So fractals are geometrical shapes that exhibit self-similarity and infinite complexity. Yeah. So we've basically created our very own fractal, where the further you zoom, you'll see the same pattern recurring, happening over and over and over again. Like this. Which is a very mesmerizing and complex pattern. But the logic is simple. It's just the same basic shape, which is this, repeated over and over again. So if I make this limit 50, you see? It's this basic shape here. Then for every line, I draw another cosh. So maybe I make this 25. Oh. I make this 25. Boom. Then you get the second iteration. Like this. Maybe I make this into 10. Then you see, 10 is maybe a bit too close. 15. See? For every line, it adds another one. For every line, it adds another one. For every line, it adds another one. Boom, 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 boom. Yeah, so you guys can try it. Try the code like this. And then play around with the condition here to see whether you guys are able to get the pattern. Any questions? Whoa, Becky, nice. Yes, you can add the colors to make it, to help you understand what's happening more. Ah, Amy is almost there as well. Oh, but your cosh is a bit tilted.
The shape is funky. It's weird.
It's weird. Ah, it's because you didn't sandwich your cosh function with two forward lines. So I think your third cosh is missing a forward command below it.
The
The
third course.
Yeah, it's the third cosh triangle command. I think it's line 11, is it? Or a bit lower than that. It's missing. It should be forward, cosh command, forward, like a sandwich.
Oh, okay.
Oh, it's gotta be before you turn, not after you turn.
Yes. Sorry, can you say it again? So should I lay down the forward again, or
You can you'll click my name and you'll see.
oh, okay.
Yeah, I'm gonna make it easier for you to read. Okay, you can click my name now. Click my name again and you should see my code. Hmm. Becky, how is it? I see you're able to create the snowflake no problem.
Thinking about how it works.
How it works,
yeah. How it draw.
So conceptually, are you stuck on why it works?
About why it's drawing like that. Trying to figure out.
Why do you think that's the case?
Just help me to know how to adjust the shape if I want to change the shape.
Ah, okay, yes, actually that's the next activity. You are supposed to change the shape. So, let me show you, let me talk about it. I think Amy's there. Oh, Amy got it too. Woohoo! Congratulations. Oh, nice. Oh, Amy just copied Becky's code. I don't know. Amy, were you able to get it?
Which part?
I see you're successful. You've made the snowflake.
Yes, I think I fixed my code by your code.
Oh, I see. Okay, that works too. Ah, interesting. Uh, Becky, that's not how you add the colors. Eh? Is that how you do it? Oh, right. You added a variable called color, is it? Ah, I see. Fantastic.
Yeah.
Wonderful, wonderful. That's smart. Yeah, that's good. Oh yeah, you can delete that now. Yeah, that's true. Line 2 doesn't require B color too. Line 2 doesn't need the color as well. Sorry, yeah, line 4 doesn't need it too. You don't need it as well. Nice. Yes. Eh? Why is that case?
Sorry.
Oh yeah, sorry. Oh yeah, you do. Oh my goodness, you're right. Add it in line 4, yeah. My goodness. This is such a beautiful way to do it. Well done. Oh my, Amy, what are you discovering?
So Searching different angle.
Change the angles. Ah, okay, okay. B color blue, pink, purple, and line 18 is nothing. It's doing white. Ah, if you don't give it a value, it's not gonna do anything, I think. 25. Oh yeah, you can start looking at it from this is the second iteration. Yep. I think if you put 20, you should do the next iteration. Oh, Amy's trying out different angles already. Okay, fantastic. You guys are there. Okay, so the next activity is that you guys have to pick your basic shape. So come and take a look at my screen. So Amy and Becky, do look at my screen. So this is what you guys have done so far. There's a basic shape that we've picked, and we are just repeating the basic shape again and again and again. Okay? But smaller and smaller and smaller. That's basically what we're doing until we hit a limit. But if we change the limit to, instead of 50, we made it to 25. So this is the second iteration. I think 20 is the third iteration. And if I do 15, it's the same. 14, 13, 12. Ah, okay. So 12 is the next iteration. That means that for every line, you draw a cosh. If I want to do it again, instead of 12, if it's 11, no, it's not 10, no, 9, 8, 7, 6, 6. There you go. This is the next iteration. But it's still the same pattern. You see it? It's still the same pattern. And it all starts from this. So because we chose this as the base shape, we will get this particular snowflake. And if I want to do it, I can make it a snowflake like this. Ah, there you go. I have my snowflake now, right? Okay, but that's because I chose this base shape. What I want you guys to do is I want you guys to delete all of this and make your own starting shape. So it could be any shape that you want, but make it extremely simple. The shape could be like this. It could be forward, I don't know, left. How should we start? Okay, maybe I should start facing up. So I'll turn left 90. Start from this, and it goes forward 50. Oh, I need to zoom in. Right 90, forward 50, right 90, forward 50. This could be my basic shape. Right, so this is no longer Kosh, I'll just call it Princeton. There you go. And once again, let's see what happens when we have Princeton repeated again and again, but divide by 2 this time. Oh, nothing happens? Okay, that's interesting. Length. Oh, because these aren't length. So if I just do Princeton, it's just doing the shape again and again. But if I divide by 2, or not here. It does this. And the wait command. Oh, there you go, spiraling in like this. Okay, but instead of that, what I want to do is I want to add Princeton. So I'll separate all the lengths first, like this. then what I would do is I would add a function, divide by 2, divide by 2. Then in between, I'm going to add a Princeton length divided by 2. So this is my recursive pattern. I don't even know what I will see. Yeah, so that's the next activity. Go and pick a base shape that you want and go and create interesting patterns that runs and create more interesting patterns. Did I answer your question, Becky? Because you asked how do I change the shape. So Amy, what's the base shape that you're going for?
You mean right now the shape I'm creating?
Yeah, what's the basic version? Let me take a look at yours.
Oops. I'm just like change the number all the time and see how it goes and figure out this one is interesting. I'm letting it run a little bit more.
Interesting.
I'm not sure like how did I create sort of circle here?
Circle?
I mean it's not a real circle, but it becomes a circle. The round shape.
You gotta take a look at what your basic shape is first. Yeah, so I mean, you mind sharing your screen? We can do it together.
Oh yeah, sure.
Whoa, how do you do that? So cool. Oh, you times two. Oh wait, does it make sense? Oh, you times two the length. Eh? Interesting. You have the maximum command limit reached at the bottom left. So it's not continuing to draw. That's because of line 22.
Line 22, the shape length.
Yeah, line 22. You're not dividing it by 2. So it's just going forever.
Oh, yeah, but if I don't divide it, then it just creates this interesting shape. Like,
Oh, it is interesting.
it's like a wait, yep, quiz.
What you could do is after line 2, you can add a B color to change the color so you can see what's happening here. Yeah. So you OL space random. Okay, now that this changes it. So what is happening? What do you think is happening? How did this happen?
The shape length. Okay, now it's showing it. Hold on. Weird.
Do you know what's happening?
Now.
No? Well, what it seems like, can you see that the circles are different colors?
Yes.
If it's different colors means that it is going through that means it's calling itself again and again multiple times to form the circle. Okay, but why is it that you're okay? What you can do is at line 7, line 9, line 13, line 15, line 21, all the spaces you go add a weight 1. So weight space 1. Yep, do it at all the spaces. and then recenter your code. To recenter it, go to the top right hand corner. Click the leftmost icon. There's 3. Do you see the 3 icons? Yeah, click the left one. Click it. There you go.
The left one?
Yep, click it. Okay. And you close your code on the right first. You have a code on the right. Can you close it? Top right hand corner across. Yeah, there you go. Okay, now zoom out. Zoom out, zoom out, zoom out. Okay. Restart the animation. So go to change your code a little bit, it should restart. Fantastic. Okay, let's see. So see, it's drawing this, then it's drawing this. Every second it's doing. You see? So it does this. Doop, doop, doop. So this is what's happening. Every line.
I assume that it's left 75.
75.
Then
Line 2, can you make it into a different number? Let me take a look. Line 2. I'm gonna play around with your code too. Okay, let me see. Okay. I see what you're doing there. Amy,
yeah.
change line 2 length above 50 to 19. One nine 19.
90.
Okay. You can remove all the wait commands. All's good. How does it do this? Oh, I don't understand your code at all.
It's not understand either. Maybe something to do with like, I don't know, I just divide with different numbering.
This is so cool. I don't know what you've made. What did you do? This is so complex. This is so interesting. Okay. What? It's going through this each time. Okay. Shape, length. Oh. Okay, why does it cross out? Length times 2. Continuous drawing until it ends. Oh, this changes nothing because length divides by 2. Oh, then it times 2. Once this ends. I got it. I see what you're doing. I get it. Oh my goodness.
Any reason why you just come back
I get
to
it.
the starting point?
Okay, let me share with you what's happening here. So,
Okay.
can you look at my screen?
Yeah.
Right. So, this is what's happening here. This is the first iteration. So I added a wait command here at the top for your code so that each time it runs random, it'll trigger a different color. So this is what's happening here. You see? So shape reaches to this line here, length times 2, and then length divided by 2. So can you notice, even though you divide the length by 2 here, but you're able to make a shape that is a constant length because you times 2 the length here. So you see the shape length never changes exactly. It just repeats and calls itself here. So let me make this weight shorter. You could see. Can you see the colors still changing? Colors are still changing.
Oh, hold on. Is it still changing? Oh yes.
Yeah, the colors are still changing. It's like I don't think you'll even move if it's 20. Yeah, only 19. So it'll keep doing this circle until shape is done. Then you'll go to length forward and you'll go length. Yeah, so if you see, it's gonna then you'll do this. You'll go forward length and then length divided by 5. Then it's gonna move smaller and smaller and smaller. You go forward. And I think there might be a right turn in there somewhere. Yeah, so it's doing this. Do you get it now?
Better than knowing. Better than 10 minutes ago.
Yeah, so adding colors and adding a weight function helps you to understand what your code is happening. So this is too complex. I'm gonna delete it all. So I want you to make a much simpler shape. Something like the triangle that we did or anything else. A much simpler shape. At most 4 lines. At most 4 straight lines. Yes, to give it a go. Make 4 straight lines and that is your basic shape. Okay, let's see how Becky's doing. Oh! I'm gonna copy her code. I see it. It's repeating itself. Ooh, nice. Oh, it goes back down. Oh. Very nice. Very nice. Purple. Oh, you want to make it different colors. Oh. Very nice. Oh. That's really nice. Wow. Purple. Purple?
just copy paste those things, so I didn't change color.
Blue. Oh, I'm playing around with your code. Oh, this is nice. This is nice. Wow. Okay, interesting. So if I make this 10, I'll make this go faster. Whoa. Yeah, this is beautiful. Wow. I'm impressed. Ah, why do you comment out the colors? The colors is fantastic.
Oh, it's a bit messy if I, cause I just copy and paste, so it doesn't have meaning when I'm reading. I see those colors.
I see, I see. Very nice. This base shape. Since you are faster, Becky, one thing I could get you to try is that if you take a look at my screen, so far your iterations are where it goes in this direction. You see the turtle has been on top of the, okay, except this one, you see, is drawn the opposite way. Wait a minute. Okay. So you see this shape? It's going forward. But the same shape can be drawn differently. So it goes forward, but it flips. It's drawn on this way. How does that work? Maybe you can make the arrow go this way instead. So forward, go back. I'm not too sure. How do you make it flip it? Turn. Yes, so instead of drawing from left to right, you can draw right to left for one of the lines and see what happens.
I don't quite understand the turtle's direction when I'm coding.
Let me think about how to explain this. How do you make the turtle walk this way instead? Maybe don't think about it in that way. Maybe think about it in terms of going this way. Does it make sense? I've got to try it out myself. But this is really good. You should put this in the Discord submission channel. This is really nice. Take a screenshot of this too. Let me play around with it. I guess the challenge to you, Becky, is are you able to find another basic shape such that your shape currently don't overlap? Does it overlap right now? I think it overlaps. Yeah, there overlaps. I know that there are some base shapes that do not overlap itself. Like for example, this one, you see? The base shape that you just created, oh, it actually is very similar to this. It overlaps itself, you see, as it grows. But there are different versions that does not ever overlap itself, no matter how deeply you go. And those are pretty interesting too. Try to see whether you could create those. Meanwhile, let me help Amy. Alright, Amy, I see. Do you mind sharing screen? Let me see where you're at. Amy. Nice. You're muted, by the way. I assume you're speaking. Alright. Show me your base shape first.
Army?
Yeah, show me the base shape. Just remove the recursion part first. So remove line number 8. There you go. So this is the base shape that you're going for?
Yeah, oopsie. Okay.
Okay. So this is the base shape. So forward 60, line number 9, forward 60 should be forward length, right? Or what's the length that you want?
Oh yeah.
Oh, do you want it to be that long? Okay, let's go with this shape. So let's see what happens when you make all the forward commands into shape. So duplicate all the forward commands. You can't do that. What you need to do is you need to copy and paste. Yeah, so you delete that first. Fantastic. Okay, so create 2 lines. So line number 5, can you copy it and paste one more below it? Copy, paste, yep. Yep, do the same for the forward commands. Paste.
Do the same for which part?
Yep, 10, yep. Fantastic, it's the same shape, right?
Yeah.
As before? Alright, fantastic. Okay, now in between all of the forward commands that you created, add in something. Shape, length, divided by a certain amount. Okay, so this is where we're at. So at line 2, change the 65 to something else. 70, 100. Okay, so if it's 100, this is the first case, right? So if every line becomes itself, repeats the shape. Like if you put, I think if you put 60, you get, this thing will happen twice. So this is the second iteration. So every forward command it just becomes itself. It's 20. It's the same iteration. Smaller number, maybe 19. 18. 1, 8.
Oh.
Oh. 5? 1? Oh. 1? Okay, 0.1? Oh. Each color represents one iteration. If you zoom out more, even more, oh, it's still going. Ooh. Huh. 0.01? Oh, the animation will be too slow. Make the wait a bit shorter so that you can see it animate faster. So line 18. Yeah. Wait. Oh, there's no waiting. Oh, this is the creation. Oh, interesting. Okay, are you happy with this shape?
I'm alright.
Alright. Well, if you click Becky's shape.
Yeah, that's really cool.
You click hers? Yeah. You know. You click mine actually. Click mine instead. This is basically her code. You zoom out. You gotta put your cursor on the shape itself. In the middle of the screen. Yeah, there you go.
Oh.
Then
Okay.
bring your cursor. Yeah, scroll out. Yeah, zoom out when your cursor is in the middle of the screen.
Yeah.
Yeah,
Okay.
bring it to center. Yeah, then zoom out. Do a bit more. Yeah, there you go. This is her. This is her
wow.
shape. Oh,
That's beautiful.
yeah.
Wow.
That's crazy, yeah.
Yeah.
Okay, I think it's a bit of a presentation time. Let's take a look at Becky's code. Okay, I'm gonna get her to present. All right. Sorry guys, we spent an additional a lot of additional time building this, but this is so cool. So yes, Becky, please share with Amy what you did. I'll copy your code.
I don't know. At the end, I was looking at Amy's code, and I have no idea how to read others' code. I'm so frustrated at my code reading skill. So my code is trying to do a kind of symmetric thing, based on the shape we just create. Kosh, the name of Kosh.
Okay.
So I made it in different shape. Different shape with some triangle, kind of triangle.
Okay. Amy, can you guess what the base shape is?
Which one?
Can you guess what Becky's base shape is?
The couch.
It is a bit different. Let me change it. So you're right. It's almost like a course, but she's made some changes. 25.
Oh, that's a basic shape.
This is
Wow.
Is this your basic shape? This is not, right? This is the
Wait, let me see.
40.
No. The left bottom. That is my basic shape. Yeah, this one.
This is a basic shape. Yes.
Oh.
It's quite simple, right?
Yeah, that looks cool.
So then once this is the basic shape. Then I think, let's see, second iteration. Yeah, so for every line that she has, she's drawing the basic shape itself. So if you see here, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So then every line becomes the basic shape. Then if we continue doing this, there you go. Can you see the larger basic shape? And then if I zoom in, you can see the other basic shapes.
Yeah.
Right? So it's just the basic shape repeated again and again. And what was this? Was this 5 previously? What? 9? So this was 9. Right. And what she did was, she has a color. So Becky, do I show there the color?
I show the color, but I didn't actually choose the color. It's just the code like on my last shape.
Wow, okay. What do you do afterwards? You did this, I think.
Yeah.
Ta-da! Very nice, very nice. Amy, what do you think? Do you approve?
Beautiful. Oh. It can be like this. Oh wow. That's so cool.
So cool. I agree. Okay, is there anything else about your shape that you wanna talk about, Becky?
No, that's all.
Nice. Well done, nice. Okay, let's take a look at Amy's code.
Okay.
Amy's code is interesting, I would say. So let's take a look at her basic shape. What would it be? It is 20. This is Amy's basic shape, which is not as easy to understand because you see how the arrowhead ends at a different direction, this way. So whereas for Becky's code, the basic shape ends at, it started facing right, it ends still facing right. But for Amy's one, it started facing right, but it ends facing left, or a bit left. So the second iteration is gonna look like this. See? And it forms this. And interestingly, I saw Amy's code here, you see? It's not divisible by 2. So Becky only used the divide by 2, but Amy used divide by 6 here. Divide by 6, divide by 6. And her lengths are not the same. This is divide by 10, divide by 10, this is divide by 5, divide by 5. Yeah, so there's more complexity in her basic shape. So let's see, this is the second iteration. Let's take a look at the third iteration. Is this the third iteration? 2019. This is the third iteration. So I can see that it is this particular shape, yeah. And then there's like a loops in the middle, right? Oh. 2. You see, then you form this shape, and you form this shape again. 0.9. And it forms this. What are some patterns that you guys noticed?
Oh.
Oh, what do you notice about this pattern? Do you see this before? Do you see this pattern before?
No.
No, are you sure? Let me show it to you. Huh?
Oh. So cool.
Why?
Yeah, why?
Why do you guys think that's the case? Any guess? Amy? Becky? What do you guys think? Why do you think that this is the case? Any idea or none at all? Like just completely have no idea why? Look at this. This is too coincidental. Right?
Yeah. Make me think about Kosh. They repeat it again. But I don't know why.
I'll put it side by side like this. Haha! Look at that. It is almost essential identical.
Yeah.
Okay. I mean, I have a reason why. I think it is the reason. But I want to hear what you guys think first. Look at this. Okay, so I think I've let the suspense long enough. So my take on it is, and I don't know whether I'm right or wrong, is that you see this length, it's divided by 10. Yeah? So at this point, I think that the length... Oh. Okay. I think at this point the length is... okay, you know what? At the final one, I'll write the length. No, label, length. The length is really, really small at this point because you're dividing by 6 each time, right? So as you divide by 6 each time, some of the lengths would disappear because, or it'll appear to it'll look like it disappeared because it's just really small because you're dividing it by 10. That's why I think that the larger shape, like 0.05, eh? 0.5, yeah, there you go. And this shape, 30, 30. Yeah, I think that the shape looks exactly very, very similar because you can no longer, like these lines here, the things that make the circle becomes really, really small, so that it doesn't matter. So the larger structure is what emerges. The larger structure is what emerges. The pattern repeats itself, but with a little bit of variation each time. Yeah, I think that's what happens. Yeah, see, the next iteration is this again. Except this time, there are more tiny bumps here. Let's take a look at what these tiny bumps are. Oh my god, it's this shape, but
That's cool.
that's cool. It's basically this shape that is happening again at the much smaller scale. Here.
Oh, so cool.
Dong, and then it's happening here. Oh yes, that's so cool. This is immensely cool. Okay, so just now it feels 0.5. So in theory, if I zoom in right now, I will get. Oh, it's a bit hard to see because it combines this to this. Ah. Okay, cool. Well, we've basically discovered that geometrical shapes has macro features. Macro means big, and then it also has micro features. And depending on how you write your, like some features are more visible at the larger scale, and some things are more visible at a tiny scale, right? And you even from the same basic shape, you could have something like this. It is tremendously cool. Oh my god, 0.1, where's everything? Yes. Okay. So this is Amy's recurring shape. I think it's really cool. Okay, I need to wrap this up because it's becoming 2 hours. But it's so much fun. Oh man, what is this man doing? Whoa. Other recursive shape.
Oh.
Okay,
Wow.
so what we've learned today is with I mean, look at this. How many lines of code is this? This is just 18 lines of code. And it's just a shape calling itself, and it's calling itself, and it creates so many complex shapes, right? What does this remind you of other than snowflakes? Any things you see in nature that reminds you of this? Can you think of anything in nature that has similar properties as this? That means from looking at it from far away, and then it looks like it has a certain shape, and then you look closer and closer and closer, then it still looks like it has that certain shape, and you go closer and closer and closer and look at it again, it looks like it has that same shape appearing. Come, make some guesses. Amy, you're muted. Do you say anything?
Sorry, my brain is not working anymore.
Not working? Okay, I'll let you off the hook, no worries. Becky, do you have any idea? Any guess? What does this come to mind? Before I reveal the answer.
Oh. Come up with
Yeah.
any.
Okay, the answers are trees. Look at trees, right? So from afar, it has a certain pattern, right? It seems to be growing in a certain way. I think a better example might be Google Maps, right? So let's say Google Maps has this at this viewpoint, it seems like it has this squiggling lines. Let's say the border looks like this. Yeah, I zoom in closer, it looks like this. As I zoom in closer, it has this jagged edge again. And then the more I zoom in, it still looks like it has jagged lines like this. Like the jagged lines never ever stop, no matter how far I zoom in. It's kind of similar to
But-
Becky's thing.
But it's not exactly the shape.
Exactly. They're not exactly the same shape. But yours is exactly the same shape. So yours are perfect, self-similar shapes at every scale. But for something like discovering what territory is, how do you define what a border of something is? It is not exactly 100% similar. But it exhibits a similar property in that at various dimensional scales, at various scales, it has similar properties. So it's not exactly a perfect fractal like yours, but it is
But you
almost
get
like
it.
it.
Yeah, I get it.
Right? And what is actually happening is that for your code, the logic is pretty straightforward. So if we take a look at the base shape of something like this, like yours, it's basically doing this. It's doing this over and over again until it hits a limit and it stops. That's what's happening when trees. That's actually how trees grow. Because for trees, what happens is that you have a branch that comes up, right? And then it will keep growing towards the sunlight, and it will keep growing until it hits a limit. Maybe it's too far from the trunk of the tree and there's not enough water. Then it will stop. Then it will grow in the other direction. It will keep growing, and it's repeating itself. It's just creating more and more tree branches. Then you'll stop at a certain point and you'll continue growing. So what I mean by that is that what you guys have done right now, this logic of repeating itself, is actually how a lot of how nature works. So let me give you an example of the tree. So using the same recursion, this is actually how tree works. See, the tree is growing, there's a certain point, then it stops, then it continues growing. Very similar to how you've drawn your snowflake here, or the snowflake that we have done earlier. Basically, it's a single cell in the tree that is growing and replicating itself, right? So biology, right? It's like cell division. It's basically a copy of its DNA and replicate. It's a cell division and it replicates itself. And then if a simple thing like replicate itself, okay, so this is basically your basic command. 50, 40. Yeah, this is your basic command. This is your basic DNA, right? And you would think, oh, how does such a simple DNA structure that I can encode it within a few lines of code like this, how does it form larger, more complex phenomenon and structure? This is basically what's happening. It's the same thing with Amy's code. See? With Amy's code, I said, what if I want to tell you, I want to build something that has this feature, this hook feature, but at all the joints of the hook. That's such a complex feature request. How do you build a geometrical shape that has hooks at each of its corners? Well, if you know that you could use Amy's basic shape, which was, I think it's like 50. Oh no, it's like 100. Yeah, with this basic shape, if you just use this basic shape and self-replicate, you could create emerging patterns that, such as this one, which is like a gun thing that has like a mini hooks at each of the corners. Ta-da! So what I'm trying to get at is, with a few simple commands, you are able to create very, very high levels of complexity. So we are basically looking into the elements that make up a lot of how nature works, like cell division, how trees grow, how snowflakes are made as well. So snowflakes are made because you have a very cold condition and you have a speck of dust, right? And what happens is that the dust will kickstart the process for the snowflake to form. And so how does the ice grow? The ice will grow out in a certain pattern following a certain basic, I don't know whether it's basic, so it'll expand in a certain pattern. Then it'll interact with the environment on the outside, and if it hits certain limits, it will grow a different way. If it hits certain, otherwise it will continue growing. So it's all encoded into how the snowflakes works with a few simple rules. Another example would be cancer cells. Yes. So you might ask, why is something like this important? Like, why is the study of this thing important? Well, take a look at these two basic shapes here. So this is actually very similar to the one which Becky has drawn, right? This way, this way, this way, this way, this way. And as you self-replicate itself, you form this pattern after a few iterations. But look at this. The problem with this iteration is that each time it self-replicates, it cuts into itself, which is not a very useful basic shape. Think about it. If you're a tree, right, you don't want your tree trunks to be crossing into each other, right? You can't have your tree trunk cross into each other. So maybe this basic shape is not a good basic shape to draw trees. But this one, you see, so each time it replicates inward this way, what you'll realize is that no matter how many times you iterate down, none of the lines crosses each other. So what happens is that this is actually a space-filling fractal pattern. This pattern basically does space maximization after a couple of, as the iterations go up. Can you see that? None of the lines crosses in on itself. So if you're optimizing for high surface area, then this would be a fantastic basic shape to choose to self-replicate. So they use this in what's this? This is a signal device. Yeah, to do space optimization. So for example, if you want to capture a couple of different electromagnetic waves, how do you do so? They use this concept of fractals to do so. Or in the case of studying cancer cells, so regular cells, what's the difference between cancer cells and regular cells? This I will have to ask Becky. Becky, what's the difference between normal cells and cancer cells?
The cancer cell will grow unstoppable.
Unstoppable, exactly, right? Cancer cells will constantly cell divide without stopping. It doesn't stop, right? So think about it. Imagine your code here, but it doesn't stop. So I'm going to remove this limit here. If I remove the limit, what happens, right? Or rather, if this limit is jammed up to be really, really, really small, then it forms. You can see it starts growing unconditionally. It just keeps replicating and replicating and replicating. So what happens is that you can study the degree in which something grows, and you can determine whether it is cancerous or not. So studying fractals is also kind of used to help study the degree of cancers, the stage of cancer from it. Yeah, so that's also one application space of what learning this will look. If you were to investigate this even further, that's what you could do with it. Yes. Okay. So just wanted to share why we are doing this. Okay, it's been 2 hours. Does it make sense? Are you guys still with me?
Yep.
Yeah.
Okay, I think I will have to stop it here. Do you guys have any questions?
I think I will watch the video you recorded today.
Me too.
Okay, yeah. So let me stop the video. I think this lesson might be a bit too long, but hope you guys had fun. Let me stop the video.